Hi students, we were discussing about carbon and its compounds in the previous video, and in that we completed some important compounds, ethanol. Ethanol physical and chemical properties we complete. Today we can discuss the physical and chemical properties of ethanoic acid or acetic acid. Okay, so it belongs to carboxylic acid, which is a weak acid. And the 5 to 8% solution of acetic acid in water is called a vinegar, and we know it is used as a preservative in pickles and all. Okay, the melting point of pure ethanoic acid is 290 Kelvin, and hence it often freezes during winter. So it is known as glacial acetic acid. That means during winter we can find a solid form of pure acetic acid. So the pure acetic acid is also called a glacial acetic acid. Acetic acid is a very weak acid compared to strong HCl acid. Okay. Now, the chemical properties of ethanoic acid. Okay, they are giving an activity for us. Take a test tube and arrange a setup like this. This is a water bath. In this test tube, we are taking 1 ml of absolute ethanol, 1 ml of glacial acetic acid, and a few drops of concentrated sulfuric acid, and warm in water bath for 5 minutes. Then pour this mixture into a beaker containing 20 to 50 ml of water. And then if you smell it, you can feel a pleasant fruity smell. Okay, that is because of the formation of ester. So what we have taken ethanol and ethanoic acid that in presence of sulfuric acid forms a special substance called ester, a fruity smelled substance called ester. This is the reaction equation. See, ethanoic acid reacts with ethanol in presence of an acid, forms a compound called ester together with the water. See, the formula of ester is wrongly written here, that we can write in a proper way. It is given wrongly in the text. You can write, see, this C is not there. This C is not there. Instead, there is O here. Okay, like this. Okay, this is the compound CH3, C double bond O, then O, CH2, CH3 is the compound. This is called the ethyl acetate or ethanoate, we can say. This is the name of the ester. Okay, ethyl ethanoate. Okay, so that is esterification reaction. What is the ingredient or what are the reactants required? Acetic acid and ethanol. Okay, and in presence of acid, constant acid only, this is esterification is taking place. So that reaction is called esterification reaction. Okay, now what is special about these esters? Esters, I've already said, it is having a fruity smell, sweet smell. So it is used to make perfumes and as a flavoring agents. Okay, and the reverse reaction is called reverse reaction. Formation of ester is called esterification, and the reverse of that reaction means breaking of ester into the corresponding alcohol and acid is called a saponification reaction. So this is equation ester, and we can do the saponification reaction by treating the ester with the NaOH. So what happens is the acid and alcohol get separated, and the sodium salt of the acid will be formed along with the alcohol. Okay, so this is ester and reaction with NaOH decomposes to the corresponding alcohol and the acid, of course, and that acid reacts with NaOH, we are getting the salt of that acid. Okay, this reaction is called a saponification reaction because it is used, the same reaction, the very much similar reaction is used for making salts. That is by the name of the reaction saponification. Okay, now coming to the next chemical property of ethanoic acid. Ethanoic acid react with the NaOH base. Okay, acid base. So what we expect, salt and water. We are getting salt and water, sodium ethanoate and water. Okay, salt and water. Acid plus base, salt and water. We have learned much before, isn't it? Now acid plus carbonate. Acid plus carbonate, acid plus metal hydrogen carbonate. Both gives you salt, water and carbon dioxide. We learned while we were learning acids and bases, isn't it? So here also we are getting salt, sodium salt, sodium acetate, carbon dioxide, water in both the cases. So that is with the NaOH and with the metal carbonates. Now they are talking about the cleansing action of soap. So okay, 10 ml of water in two test tubes, A and B. To one we are adding cooking oil, and to the test tube we add a few drops of soap solution. Shake the test tubes. To both the test tubes we are adding cooking oil. Okay, to one test tube only we are adding soap solution. So both the test tubes are having water and cooking oil, but in one solution water, cooking oil and a soap solution. Now shake the test tubes vigorously. Then you can see that it forms an unclear mixture. Then allow it to settle down. Then we can see that oily layer separates out in both the test tubes. But this happens first in the test tube A. That means separation of the oil and water is taking place in a faster way in the first case, where there is no soap solution. If there is soap solution present, the separation will be taking place in a slow manner. Okay, which shows the cleaning action of soap. Okay, so soaps can be used to clean clothes or whatever it is. Okay, that why it is possible, this is the structure of a soap molecule. Okay, exactly this is what is soap molecule looks like. A long hydrocarbon chain and a head with the ionic end. Okay, or this ionic end is otherwise called a hydrophilic. Hydrophilic means water loving end, and the hydrocarbon end is called the water hating hydrophobic end tail. Okay, so a soap molecule is having a hydrophilic head and a hydrophobic tail. You can draw simply like this: a head with hydrophilic head and a hydrophobic tail. Okay, well, this is having a charged end. That is why that's also called ionic end. The other one is called a hydrocarbon end. Okay, so ionic end or hydrophilic end, hydrocarbon end or hydrophobic tail. Okay, that is the structure of a soap molecule. So this shows the structure of a soap molecule and what happens when it is coming to actually it is sodium or potassium salt. Okay, so when it is meeting, when we are applying soap into clothes and all, what happens is when a soap molecule meets a dirt or an oil, the hydrophobic end, okay, hydrophilic end will be interacting with the water present, whereas the hydrophobic end will move towards the oily dirt, and it will stick over there and it forms, and nearly hundreds of soap molecules attached to a single droplet of oil and forms a special structure called a micelle. Okay, and then I can drive the micelle away very easily. We can rinse it away. See, the picture shows oil or drop coming off soap molecules. They are coming and attacking or getting attached to the soap dirt and forms a special structure called a micelle, which can be rinsed away very easily. Okay, so this is a micelle which can be driven out very easily. Okay, by rinsing with the water. That is the how the soap cleansing action of soap is coming to active. Okay, effect. Now, if you have water containing sulfates, chlorides, or hydrogen carbonates of calcium or magnesium, then it is called a hard water. Now, what I have to do is we have to take hard water and soft water in two test tubes. To one we are adding soap solution, and to both the cases we are adding soap solution, and we can see that shake it well. And we can see that in one case, uh, foam is formed, okay. But the other case, we are getting a precipitate only, scum will be formed. Now, why? Because the soap molecules in the hard water, okay, uh, is going to react with the calcium and magnesium salts present in the hard water and forms the precipitate or scum. Okay, so it will soap will not lather for form lather in the hard water. Okay, because it reacts with the calcium and magnesium salts present in the hard water to form a precipitate. Okay, the scum or a precipitate is caused by the reaction of soap with the calcium and magnesium salts. Okay, so how can we overcome? We can overcome that problem by a class of group of salts called detergents. They are actually sodium salts of sulfonic acids or ammonium salts. Okay, or ammonium salts with the chlorides or bromides ions. Okay, so sodium salts of sulfonic acid. That's, it is given the structure, you don't have to study it anyway. About how long hydrocarbon chain. But what is special about that? The charged ends of these compounds, that means the detergents, the charged end do not form scum with the calcium and magnesium ions present in the hard water. So that means it is effective in hard water. It do not form precipitate with the hard water. Okay, that is specialty of detergents. Now, that can be demonstrated by what is an activity. Okay, there's a test tube. We can take two test tubes with hard water. In one we are using soap and one we are using what detergent. And in the case of detergent, you'll be getting more lather. Okay. Then uses of detergents. They are used to make shampoos and products to clean clothes. Detergents. These are all the some of the products made from detergents. Okay. And that's all for this video. The next video will be discussing about the board questions. Okay. Thank you.